So another type of everyday force you would experience that's rather important is friction. Um, Friction is a part of everyday life. Removing a fried egg from a frying pan is easier if we have a non-stick surface. You find that running is easier on a dry sidewalk than it is on ice. Skiers wax their skis to reduce the friction between the skis and the snow to make them go faster. And cars need friction in order to speed up, slow down, or go around corners. So in order for a tire to start moving, it has to catch and kind of start pulling off the floor. In order for it to slow down, it has to increase the amount of friction so that it starts to slow down. Friction is a resistive force, so it always resists motion. It acts in the opposite direction of the direction of motion. It occurs because of electrical forces between the surfaces where the two objects are in contact. So it's actually an electromagnetic force. It's the electric repulsion between the atoms in one surface and the atoms in another surface. One of the types of friction we have is called static friction. It's the force that tends to prevent a stationary object from starting to move. Another way we refer to it is as the starting friction. So you have to actually overcome the static friction in order to get an object to start to move. And then it actually has less friction. It has a different type of friction, which we'll get into soon, which will be less than what its starting friction was, or its static friction. So once it's starting to move, we have kinetic friction. And kinetic friction is the friction force that acts against an object that is currently in motion. There are different types of kinetic friction. Sometimes we call it sliding friction, rolling friction, or fluid friction. They could also just be considered under the umbrella of kinetic friction. So again, it's a force that acts against an object that is in motion. It is actually it is always less than the or equal to the static friction. This slide here talks about how we have controlled friction over the years of our use of technology. About 4,500 years ago, the Egyptians built enormous pyramids using huge stone blocks that were difficult to move by sliding. So they actually placed logs beneath the blocks to push them and move them. And by doing this, they take advantage of the fact that rolling friction is less than that of sliding friction, because there is less material in contact with the surface. Modern technology uses the same principles as the Egyptians, though in more sophisticated ways. All machines have moving parts that experience friction during operation, and friction can wear out the machines and reduce efficiency. So, excess friction in machines can be overcome by making the surfaces smoother, or replacing them or lubricating them, using bearings, ball bearings, instead of flat surfaces is another way. That way there's less surfaces in contact with each other. And using smoother surfaces. So this slide here gives you some ideas of how we can control friction. Friction can wear out machines and reduce efficiency. So we control it by making surfaces smooth, replacing surfaces with ball bearings, lubricating, or using materials with little friction, like smoother surfaces. Ways of reducing undesirable friction in other situations are also common. The wax applied to skis reduces sliding friction. A layer of air between a hovercraft and the water reduces fluid friction. The human joint is lubricated by synovial fluid between the layers of the cartilage lining the joint, and the amount of lubrication provided by synovial fluid increases when a person moves. In fact, our lubrication systems work so well, it's difficult for technologists to design artificial joints that function to the same standard. So friction, sometimes it's undesirable, but it also has some uses. For example, in South America, where there's many earthquake zones, buildings have a tendency to crumble during an earthquake. To help overcome this problem, Incan stonemasons developed great skill in fitting building stones together very tightly, so that a great deal of sliding friction would help hold the buildings together even during an earthquake. Another way we control friction is through the non-stick material known as Teflon. So Teflon is a material that is sprayed onto pans. It makes it more difficult for materials to stick to it. It has a very low coefficient of friction. Here are some questions. It says, where are situations where friction would be helpful or would make things more difficult? So turning into doorknob, if a doorknob is very greasy, for example, your hand wouldn't be able to grab a hold of it, so that would be, having friction is helpful in that case. Streamlining in the transportation industry, well, in that case, we are trying to reduce friction, so friction is actually difficult. So streamlining means that cars and trucks are built in such a way that they move the air away from them to cause less turbulence due to friction. Pushing a heavy box across a rough surface. Well, that way, there the friction is going to be difficult, making things more difficult for you. When tying a knot, friction could be helpful there because you need it to kind of grab hold of the rope, but it also could be not as helpful because it could make it more difficult for you to tie the knot. A car going around a curve, well, in that case, friction is helpful because if the car didn't have good hold of the ground, it could fly off the road and not make the curve. And our last slide here, it says a typical bicycle braking system involves a lever that you pull on the handlebars and a brake pad near the rim of the wheel. So describe how this braking system works. So when you pull on that lever, the brake pads make contact with the wheel, usually your front wheel, and they basically apply a lot of friction to your front wheel, which causes your front wheel to slow down and eventually stop. So it's through the use of friction that we slow down a bike using the braking system.